we're going to have the easy way of finding derivatives where we don't have to take any limits. And the easy way to find derivatives of polynomial terms, something like we're going to find the derivative of x to the n. All we do to find the derivative, to find the slope at any value of x, is bring that exponent around front and then multiply by x and decrease the exponent by 1. So if I had something like f of x equaling x to the 5th power, the derivative f prime of x, without taking limits, I bring the exponent around front and I multiply by x to the, and I just decrease that exponent by 1. And that is going to be the slope of this function at any x value. Now there's some other rules that go along with this. We're going to talk about the other rules, but that is the easy way of finding the derivative of polynomial terms. Now what if we have a coefficient in front of that function? Well, what we're going to say is coefficients come along for the ride. So I'm just going to take that coefficient and multiply by the derivative of the function. So take the derivative of the function like you normally would, and then just multiply by whatever that coefficient was, because it comes along for the ride. Now with those two things in mind, let's take a look at some examples. We've got x. What is the derivative of x? Well, think of it as x to the first. So the derivative is going to be 1 x to the 0. Well, things to the 0 power have a value of 1. And so the derivative of x today, tomorrow, and forever is going to be 1. B. Now before we take the derivative of this, we're just going to rewrite it. And we're going to rewrite this as, this is the same thing as x to the 2/3 power. So the derivative is going to be, let's bring that exponent around front, and then let's multiply by x. And if I decrease this by 1, if I decrease it by 3/3, my exponent is now negative 1/3. So that drives it down to the bottom of the fraction. To write it like this is absolutely fine. To say this is going to be 2 over 3x to the 1/3, also fine. Different ways of writing the correct answer. 2 over 3 cube roots of x, also fine. Now here we have that constant multiple rule, or that coefficient, and what we said is that the coefficient comes along for the ride. Now let's take the derivative of x to the 4th. 4 comes around front, x to the 3rd, or 12x to the 3rd. Letter D. Let's think of that as x to the negative 2, because we're pretty good if we have an exponent. Now let's find the derivative of that. Well, the rules don't change. You bring that negative 2 around front. You decrease the exponent by 1, making it a negative 3, and that's the correct answer. Now you could write it as negative 2 over x to the 3rd, and that would be fine. And then there's 7, or any constant. Well, think of it Well, I get 7x to the 0. So 7 come along for the ride. Then bring the 0 around front, x to the negative 1. Well, 7 times 0 times anything is going to be 0. The moral of the story is, you got yourself a constant, the derivative 100% of the time, today, tomorrow, and forever. Derivative of constant is 0. Other properties. These are pretty easy. The derivative of some function plus another function can be found just by taking the derivative of this first function and adding to it the derivative of the second function. If you find that easier, just find the derivatives separately and then add their results together. Same thing happens when you're subtracting. You just take the derivative of the first guy and subtract away the derivative of the second one. Oh, and that's that for that slide. Love that. Okay. We're going to learn how to handle derivatives that are written in fractional form in a little bit. But if those functions written in fraction form can be simplified, do that first before you try to find the derivative. Let's rewrite f of x. Let's take x squared and divide it by x, because I can simplify that. It's just plain old x. Minus, what's 2 square roots of x divided by x? Think of this as 2x to the half divided by x to the 1. And when we're going to simplify this, I guess I got to subtract those exponents, and the one on bottom's bigger. So I think this is going to be 2x to the negative half. So now let's find the derivative. Well, the derivative of x we have said today, tomorrow, and forever. Always 1. Minus 2, you're a coefficient, you come along for the ride. Let's bring this exponent of negative a half around front. And then let's decrease the exponent by 1. Now that's going to take a little bit of cleanup. We got 1 minus. So that's going to cancel at that. This, I guess I could just write as negative 1 or negative x to the negative 3 halves, or let's see, minus a negative turns this into plus, and I'm going to have 1 over x to the 3 halves, because I think we're more comfortable writing things with positive exponents. That would be the derivative. That would be the slope of this function at any value of x. So if I'm asked to write the equation of a tangent line, I now know how to find the slope. Oh gosh, wonderful. Well, let's write the equation of a tangent line and a normal line. Well, we're going to have to talk about normal line, I'm sure. Let's focus our attention on tangent line. Now let's write this in point-slope form. Point-slope form, here's the point, 432. And in point-slope form, what I'm going to write is I'm going to write y minus whatever the y value of that point is. So y minus 32. Now I have to find that slope. times x minus whatever the x value is in this case. All right, now let's find the slope. Well, if y is equal to this, then y primed, the derivative, the slope. Let's see, let's bring that 5/2 around front. Let's decrease the exponent by 1. And now, let's focus our attention on when x is 4. So we need 5/2 times 4 to the 3/2 power. And AP is going to expect you to be able to do that without a calculator. So what is 3/2 power? What does that mean? Well, that means 5/2, 4, and that means the square root of 4 to the 3rd power. Now, what I think is always easiest is to take that root first. What is the square root of 4? You'd say 2. And 2 cubed is 8. So this has a value of 8. If you think of it this way, take the square root of 4, which is 2, and 2 cubed is 8. The other way to do it, you're dealing with bigger numbers. What's 4 cubed? Well, that's 64. What's the square root of 64? And 5/2 of 8 is equal to 20. So the slope is going to be 20. And there's your tangent line. Now, what the heck is this normal line? Well, realize what a normal line means. A normal line means perpendicular to the tangent. So I have the tangent line, I just have to write the equation of something perpendicular to it. And so I'm going to write this the exact same way. I'm going to say y minus 32, because it is still going through the point 4, 32. We're still going to need a slope number. And multiply by x minus 4. Now, what do you know from previous math classes about the slopes of perpendiculars? Are you thinking they're opposite reciprocals? So what's the opposite reciprocal of 20? For a normal line, all you have to do is find the equation of the tangent and then write the equation of a line perpendicular to it. So point slope form is a real nice, convenient, easy way of writing the equation of a line. Well, now let's calculate the derivative of x times x squared. Well, you probably listened to what I said before. And what I said before is, let's simplify first. This would be x to the 3rd. And so what's the derivative? What's f primed of x? And that should equal 3x squared. And you're absolutely right. But what happens if you have something that can't be simplified or is really difficult to simplify? Now, do not do what I'm about to do. There are people who say, well, I think what you do is you take the derivative of this times the derivative of this, and there's your derivative Well, that's not right because the answer is 3x squared, not 2x. So forget that green stuff. That's no good. No, there's a special rule when it comes to multiplying two functions. That special rule is called the product rule. And the product rule says this. Let's say we've got f of x is equal to some function, let's call it g of x, times another function, h of x. So we're multiplying two functions together. The derivative, and I'm going to start right over here, and I think you should too. The derivative is found by taking this first function times the derivative of the second guy plus that second function times the derivative of the first. Now, we could simplify this one, but let's just demonstrate the product rule using that function. Let's say that f of x is equal to x times x squared. And we're not going to simplify, just to demonstrate the product rule. So f prime of x, and I know the answer better be 3x squared. I've got to take that first function, which was an x, times the derivative of the second function, the derivative of x squared, plus I'm going to take that second function, which was x squared, and multiply it by the derivative of the first function, and the derivative of x is 1. Well, I'm going to have 2x squared plus x squared, which is indeed what we expected. So that is a demonstration of how the product rule works. I wouldn't use it if I could simplify. But if I did, I would end up with the correct answer. Now, a little more complicated is the derivative of a quotient. And yeah, it would be really nice if I could just, if I want the derivative of this thing, if I could just take the derivative of this term and the derivative of that term and the derivative of that term, and this should have been a minus, and I'm sorry about that, divided by the derivative of that term. But no. No, that doesn't work. Nope. For a quotient, for a fraction, we got other things to do. If I say that we've got a function f of x equaling maybe g of x over some other function, now the derivative of f of x, f primed of x, is going to be, this is kind of complicated. It's the thing on the bottom, which is h of x, times the derivative of the thing on the top, minus the thing on the top, times the derivative of the thing on the bottom, divided by that bottom thing being squared. Well, yeah, that's kind of complicated. How are we going to remember that? I mean, product rule's not bad, but this is tough. All right. took the thing that was down low and we multiplied it by derivative of what was up high. Then we subtracted the thing that was up high and multiplied that by the derivative of what was down low. And we divided by low times low. Well, you might say, Mr. Kotz, that is just absolutely not easier. But say it with me. We've got low d high minus high d low over low low. Low d high minus high d low over low low. If you remember what those terms mean, the thing on the bottom, the derivative, d, the derivative of what's up high, low d high minus high d low over low low. And if you say that to yourself several times, you will never, ever forget the quotient rule. Now, if I look at something like this, I'm seeing something that I cannot simplify easily. And so I'm going to find the derivative. I'm going to find f prime of x. So I'm going to take what's down low, multiply by the derivative of what's up on top. Is that good? Derivative of that, derivative of that, derivative of that is nothing. So I did low d high minus the thing that's on top. D low, the derivative of what's down on the bottom, over low low. Now, what I want you to do and what I'm going to do is you guys are going to FOIL this thing out. So am I. You guys are going to distribute the 2x. So am I. And then we're going to combine like terms. We're not going to do anything with the bottom. We're not going to multiply that out. But multiply out the top, combine any like terms. Let's come up with a final answer. Let's pause and do that. So when I multiplied these guys, I got what you see in red down here. Hopefully that matches up with you guys. When I multiplied these guys together, well, that's what I had in blue. And I had to remember to subtract that entire thing, so I put it in parentheses. And then I combined those like terms, and this is what I got, hopefully without making any mistakes, as the slope of this function, as the derivative of this function at any value of x. Now all of this is going to take some practice. You're going to have a chance to practice that this evening with the assignment you're going to find in Schoology.